All right, this is going on page 29 when we are done. And like I was saying, some of this is a review, some of it may not be for you, but none of it is crazy difficult right now. All right, so we have some critical points. Critical points are where the graph changes direction or shape. Okay, where it changes its direction or shape. So we have two things in our critical points list right now. Extrema, that's the plural for the word extreme. Okay, so extrema are points where the graph changes its direction. The function has minimum or maximum value at these points. So here's my graph. I'm increasing, here's my maximum, and then I'm decreasing. So that's what it means by the change of direction. Then we also have what's called a point of inflection. That's where the graph changes its shape, okay, but not its direction, okay, but not its direction. So here I'm decreasing. I changed the shape, but I didn't change the direction because I'm still decreasing. It's just going quickly. It slows down, and then it speeds back up, okay? So the point of inflection is what gives you that little zigzag, and then the maximum and minimum is what gives you the complete direction change, okay? We all good? Talk about maximum and minimum in Algebra 2? Should have at least talked about maximum and minimum, maybe not increasing and decreasing. But so we have two different kinds of each, basically. If we have a point with the greatest value, but the greatest value compared to points around it, so not necessarily the greatest value overall. The greatest value compared to points around it is called the relative maximum. All right, so it's relative to that interval that you're given. So for instance, in this graph right here, if we are looking at the interval that maybe goes from like -10 to 0, so on this interval, just looking at this section of the graph, this would be my relative maximum, okay? Can also be called a local maximum. But then the point with the greatest value over the entire domain, that's called the absolute. The absolute maximum. So when I'm looking at the entire graph, overall, this is the greatest value. And remember, when you're talking about the value of the function, that's the y value, right? We're looking at the intervals on the x's, but the greatest y value overall would be this. That's what makes this an absolute maximum. Okay, we good with that? Easy enough? All right, so then least. Oh, actually, look at this down here. You see how on this graph, this would be a maximum. Would it be relative or absolute? Relative, right? Because it would be just relative in this little domain right here. Do I have an absolute maximum in this graph? No. Okay, because if you think that the absolute maximum is infinity, then the absolute maximum doesn't exist, right? So you remember that? Because infinity is not a number, it's not a value. So we're looking at the greatest y value, and we'll never get there. So although this one has greater y values than this one does, it doesn't even have a maximum because on both sides of the graph, it's going to infinity. Does that make sense to you? Okay, good deal. All right, so then the point with the least value compared to points around it will be our relative minimum. And then the least value over the entire domain is going to be the absolute. Oh. Everybody good with that so far? Okay. So largest and smallest values should kind of make sense for minimum and maximum. So our examples down here says give the coordinates and classify the extrema for the graph of each function. Then it says use your graphing calculator to approximate if needed. All right, so we're not doing that because it's just kind of honestly a waste of time at this point, because on number 1, you have the skills to actually find the absolute max or min algebraically because it's a quadratic and that you can find the vertex of that. But on number 2, for you to find those critical points, it requires calculus, which I'm not teaching you because this isn't a calculus class, right? So in pre-cal, we just look at, we have to make sure that we know what a maximum and minimum is, the relative, the absolute, and that we can identify it. and understand how it works and what its purpose is. And then the algebraic part of it, you get into that in calculus, okay? So instead of using the graphing calculator, because all we'd really be doing on there is either tracing or having it find it for us, and that's not really teaching us anything anyway. It's the concept of what it is what's important. So we're going to estimate off the graph, and we're going to estimate kind of poorly in some cases, because again, we're just going for the concept here. So number one, the critical points. How many critical points do I have in number one? Just one, and it's right here, right? So that ordered pair would be what? Oh, yes, it is a relative minimum. Is it a relative minimum or an absolute minimum? Which one? Absolute, because overall that is the smallest one. What's the actual ordered pair here? 4, -5, good. So then this is an absolute minimum. How many critical points do I have in number 2? 3. So I have one right here, I have one right here, and I have one right here. Now when we estimate, we're going to estimate to the nearest 0.5. We're not going to worry about, should it be 0.3, 0.2? We don't care. It's fine. It's either at a whole number or half the way, and it's good enough because, again, we're just looking at the concept. So this point right here, we can say that's at negative, what, 1.5 and 3? Is that a maximum or a minimum? Maximum. Would it be relative or absolute? Absolute. Very good. So an absolute maximum. This point, we can say it's like at 0.5 and 1, 2, 3, negative 4.5, I guess looks good. You'll let me know if I'm counting wrong because sometimes these look double up here to me. And is that maximum or minimum? Minimum, absolute or relative? This right here, because we're looking at this point. Are there y values that are less than this y value? Yes. If that's the case, then this cannot be absolute, right? Does this function have an absolute minimum? No, because it goes to infinity, right? So it is a minimum, but this is a relative minimum. So then let's look at this one. This point right here, that'll be at 1.5. And then what do you think? Negative 2.5? Okay, maximum or minimum? Maximum. Relative or absolute? Relative. Very good. All righty. Any questions at all? We good? Awesome. All righty. So this next one, still just estimating. I want you to go ahead and, since my phone is ringing, I want you to see if you can find these points, write down what they are. All right, so on number 3, how many critical points do we have? 2, okay. So we got one right here and one right here. Start with this one. Let's see, that would be what? What point is that? Negative 3. And then what? Negative 5? Yes? Okay. So is that absolute or relative? Relative min. Good. So this is a relative min. Alrighty, so then the next one, maybe negative 0.5. Then what? 4.5. Okay. And what's that going to be? Relative maximum. Very good. Now, the directions actually said identify the extrema. What they should have said, and we'll fix that on the assignment, is identify the critical points, because I want to identify all of them, not just the max and the min. So how many critical points do I have here on number 4? 3. I got one right here, and one right here, right? So let's look at this one first. So that would be a negative 1.5. 1, 2, 3, 4, 6. And what is that? Is it relative or absolute? Relative, because it's a max and there are numbers higher, so this is a relative max. Right? So then let's jump to this one. So this point here, that point is 1.50. Absolute or relative? Relative, right? Because it's a minimum, right? And this goes down here, so it's not an absolute, so it is a relative minimum. So now let's look at this point. This point here is 0.3. Is that a maximum or a minimum? It's a point of inflection. Very good. It is a point of inflection. Okay, so that point of inflection, I want you to look at what's happening because we're about to talk about increasing and decreasing here. So this max and min, when see how my function is increasing, I hit that maximum, I change direction, and it becomes decreasing, right? So one of the things that you should be very familiar with that has a point of inflection is that cubic function. So your parent function for a cubic looks like this, right? And what happens with that cubic is that there's a point of inflection right there. If I was to take the left-hand side and reflect it in the x-axis, it would be a parabola, right? So a cubic function is like a parabola that's been twisted. So if I have a parabola that opens up, we say that that's concave up. When it opens down, it's concave down. Okay, so do you understand the concept of concavity? You probably talked about concavity with lenses and stuff in science, so hopefully you understand. But that's your basic concave up, concave down. So your maximum and minimum is a change of direction. It's where it changes from increasing to decreasing or vice versa. Your point of inflection is where it changes from concave up to concave down or vice versa. So when we're coming here and we're increasing, do you see how that part of the function is concave down, like it opens down? Once it hits that point of inflection, then it's concave up. So when we're talking about these, again, right now we're just identifying them, but in calculus, they become a lot more important and tell you a lot of other things. One of the things we're going to need to know where the point of inflection is and these types of things is when we're sketching it, and we don't really know what the graph looks like, it helps us get that shape and that little zigzag in there. So that zigzag is your point of inflection. Okay? We good? Yes? All right, right now it's just identifying. Let's talk about increasing and decreasing, which is, again, is something you may or may not have done in Algebra 2. So when we're moving from left to right, the function can increase, decrease, or remain constant on certain intervals. This is not a difficult concept. Where the confusion comes in for some people is what we're looking for, but then how we write it, because you're looking at one thing, but you're writing something else. So when where it says we're moving from left to right, so we're moving along the x-axis, looking at what's happening to y. So as I move along my x-axis, and I'm starting way out here at negative infinity, right? And as I move along my x-axis, so x is always increasing, I look at what's happening with y. Well, my y values are doing what right here? Increasing. So as x increases, y increases, right? So starting out at negative infinity, my increasing interval starts at negative infinity. It keeps increasing all the way to here, which is -1. You with me so far? This is an interval, so we have to decide if we're doing parentheses or brackets, like are we including it? We never include infinity, so open parentheses there. Do you think you include the -1 or not? Just like, what do you think? Yes? Okay, so we're going to leave it open for just a minute, and then we're going to come back and talk about that and figure out if that's right or not. So then once we get here, what's happening here to my y values? They're constant. So it's constant from -1 to where? 4. Oh, did you say you had a question? Okay. So do I include the -1 here? Yes? Okay, so if I include it on the increasing and I include it on the constant, then that means it's increasing and constant at the same time. Can it be both at the same time? Think about that. No, you can't be increasing and constant at the same time, right? So if I include them on both, that doesn't make any sense. If I include it on just one, which one would I include it on? Is one better than the other? Right? If you don't have a good way to argue why it would have to be increasing or it would have to be constant, we can't, at -1, it's not either one because that's where the change happens. Does that make sense to you? So we don't include it at all. Even though that's a closed, no, we don't leave it open. But we don't put a bracket there. We put the parentheses. I just left it open for a minute. I wasn't going to leave it like that. So That's why they're always open, because at those points where the change happens, it's not increasing or decreasing or constant. Okay? So then that means the 4 I'm not including. Then from 4 on, what's happening? It's decreasing, so from 4 to infinity. Okay? Everybody okay with that? Is that simple enough? There's a chance that even though it's like seems super simple, that when you're thinking through it, you start to second guess yourself and think about it backwards, and then you go back and forth on what to do, and then you're just so confused you don't know what's happening. So I'm going to try and break this down and make it simple for you so that you don't get confused when you're writing it. So what you're looking at here is you are looking at what happens to y as x increases. Okay? So x is always going from left to right. X is always increasing. Is y increasing or decreasing? Because the function value is the y. Then when you go to write your answer, what you are writing are intervals of the domain. So although we are looking at what is happening to y, you are writing intervals of x. And that's where sometimes your thought process starts to get backwards and mixed up. So on these instructions as well, it says give the intervals on which each function increases or decreases, and then we're not using the calculator. We don't really care about that. When we look at number 5, just tell me first of all, what kind of function is it? What is that function? Absolute what? Well, there is one. Yes, you're right. There is an absolute minimum. Good job. But this is an absolute value function. That's okay. Your brain should be thinking that too. You recognize it. That's great. There is an absolute minimum there, and it is an absolute value function, right, that's been transformed. Okay, so with parent functions, we got to be able to recognize the graphs. That doesn't help me with this question, but it is an absolute value function. All right, so is this function increasing anywhere? Yes. So as I'm going from left to right, it's increasing starting here, right? So even though this y value is -4, I don't care. I don't care what the y value is. All I care about is that it starts to increase right here. So I'm starting at, it's an x interval. I start at 3, and I go, it keeps increasing how far? To infinity. And then it's decreasing from where? -infinity to 3. Everybody good with that? Super easy. All right, so number 6. What type of function is number 6? It is a rational function. It's a line that's been blown apart, right? So on this rational function, do I have any asymptotes? Yes. How many do I have? 2. Only one of them really affects how I write these answers, but there are 2 of them. There's a horizontal and a vertical. So as I go to look at my increasing and decreasing, is this function increasing anywhere? As we look at it from left to right, no, exactly. So don't be thinking, oh yeah, see it increases this way, because you're always going from left to right. As I go from left to right on my x-axis, you see how these y values decrease, 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 right? And then I jump over the 5, come up here, and I'm still decreasing the whole time. So the y values are always decreasing. Does that make sense to you? That means there are no increasing intervals. There's none. So even though it's decreasing for the whole time, can I just write one big interval? No, because there's parts that don't exist there, right? I know I'm starting at -infinity, and then I think it's -5. 1, 2, 3, 4, 5. Yeah, so that asymptote would be there at -5. So -infinity to -5, but nothing's happening at -5, so then from -5 to infinity. If you didn't know it was a rational, you may not be sure that you had asymptotes there, right? So what type of function do you think number 7 is? Think about 7. Somebody else. Does it look familiar? Yeah? What is it? What is it? Exponential. Okay, good. So if you have them, that's a good thing. He said, I got to go back and look at my Algebra 2 notes. If you have them, I'd dig them out from wherever they are. You might want to keep them handy as you're going through things because they really may help you. So this is an exponential function. Does an exponential function have any asymptotes? Yes, how many? 1. There's only 1 in an exponential, right? It may look similar to that, but your asymptote here is horizontal, which isn't going to affect our answers. It's important that you know what it is and that it's exponential, so you don't think that maybe there's an asymptote over here. Does that make sense to you? Because there isn't. If there is, that would change how we answer the question, but it's not. It just keeps on going. So it's increasing from negative infinity to where? To infinity. I don't need to count because there's not an asymptote here. If there was, then I'd have to stop there, but it's exponential, so it's going to keep on going, and it's infinity. Which means, what's my decreasing intervals? None. All right, we good? Number 8, when you look at that graph, what does that look like to you? Possibly. Okay, yes, but as far as your parent functions are concerned, I'll give you a hint. On these, they gave you the equations, so, you know, they're like right there, just saying. What's that exponent?
Oh, it's a cubic.
It's a cubic, right? It's a cubic. It's going the other way, and it's kind of drastic because there's transformations happening, but that shape should make you think cubic, or at least have an odd exponent, because we'll look at the fact that there's other ones that actually look like that, but for right now, the fact that that might be a cubic is something that hopefully should pop in your head. Again, doesn't help you with this problem, but something we need to know. But we're ignoring the equations because we're going to start estimating again. Is this increasing at all? No.
Oh, yes.
Yes. From, starts here, right? So do I start at -2? 0, because although I'm looking at the y, I write the x's, right? So it increases from 0 to what? What's our estimation? Like 2.5? Yeah, that sounds good. And then decreasing then from negative infinity to where? 0, and then from 2.5 to infinity. Okay, everybody okay with that? Alrighty. Next one. Do we have any increasing going on? Yes. So if we make this point big enough, we can say that it starts at, it's at -2, right? So from -2 to where? 0. And then also from 1 to infinity. That means that all of the other pieces, since there's no constant, we got to make sure we come up with all of it. So you can go about this 2 different ways. You can do all your increasing, then all your decreasing, or you could just go from left to right and say, okay, that's decreasing, then increasing, and just keep them straight, whatever makes the most sense to you. Just make sure you don't forget anything. So I'm decreasing from negative infinity to -2. And then where else? 0 to 1. Very good. Now, you see these points that I drew in here? So that's kind of like our breaking points on these intervals. What are those things? What kind of points are they on my graph? They're critical points, specifically maximum and minimum, right? Because that's where your direction change happens. I'm decreasing, I hit a minimum, whether it's absolute or relative. Then I start increasing, then I hit a maximum, then I start decreasing, then I hit a minimum, and that's what those points tell you is where that change is, okay? All right, so let's look at 10. Do we have any increasing? Yes, starting from where? Negative infinity to -1, yeah. And then also increasing from, well, we'll say that's 1 to infinity. Now what's this point right here called? Point of inflection, very good. So do I need to split up my decreasing intervals? Or is it decreasing the whole time there?
No, you have to split it.
It's decreasing the whole time. Because remember, this is what it looks like, kind of zoomed in. But it's coming down like this. I can do it from the side. Coming down like this, and then it changes direction. So it's decreasing, it just slows down, and then it speeds back up. But the y's are still getting smaller the whole time. So even though it has that zigzag there, you don't have to break it up, and it's decreasing from -1 to 1. What, mine? Oh, yes, but that's because it slows down a whole lot. Kind of like when you, kind of like that one up there. Some of them look straight when you're going by the asymptote too, right? All right, questions? All righty, let me hand out the homework, and then I want to make sure I give you some information on there. All right, so look at the back of this assignment. The back of the assignment says, did I miss you or something? Oh, thank you. Says give the coordinates and classify the extrema. I actually want this to be not just the extrema, but the critical points. Right. For the graph of each function, and then you can mark out the use your graphing calculator if needed. That's really just going to make your life more complicated. It's not going to help you make it easier. You don't even need it. Just estimate in a decent fashion. And then on the second half also, just mark out the using your graphing calculator. The front part of your assignment goes with yesterday's notes. The back part goes with today's notes. Okay? You have a lot of time left. Make good use of your time. You're going to work until the bell rings or until I tell you to put up.